Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 22, 2025, just yesterday. This paper introduces a new framework for robotic agents that achieves an 84.4% success rate on the complex Libero benchmark. The paper is titled ThinkAct, Vision Language Action Reasoning via Reinforced Visual Latent Planning. And as we'll see, its ability to self-correct when things go wrong is really impressive. The authors propose a dual system framework that allows an AI agent to think about a plan before it acts. Alright, so this first figure really visualizes that core idea. On the left, we see the thinking process. It's guided by what the authors call action-aligned visual feedback, which is a clever reward system. It checks if the robot actually completed the goal and if its movement path or trajectory was efficient. This feedback then improves the model's reasoning using a technique called group relative policy optimization. This process enables impressive abilities like long horizon planning and, as the diagram shows, even self-correction, where the agent notices it dropped an object and replans its actions. This figure gives us a more detailed look at that architecture. On the left, a reasoning multimodal large language model, which is a powerful AI that understands both images and text, creates a plan. The quality of this plan is improved using a clever reward system that checks for both goal completion and path efficiency. This learning is driven by a technique called group relative policy optimization. Then, on the right, a separate, fast-acting model takes that plan and executes the physical movements. This separation enables the slow thinking, fast control that is so effective. Okay, so moving to the results. This table lays out the hard numbers. It's comparing ThinkAct against other vision language action models, which are AIs that understand visual and text commands to perform physical tasks. The tests are run on two big benchmarks, Simpler ENV and Libero. And as you can see, the ThinkAct model, listed as ours, consistently gets the best overall scores, which are highlighted in bold. For instance, on the very challenging Libero benchmark, it achieves an 84.4% success rate, a clear win. This really validates the power of that dual system architecture. Building on its success in physical tasks, this next table shifts the focus to embodied reasoning. It shows how ThinkAct performs on benchmarks like EgoPlan Bench 2 and RoboVQA, which are designed to test an agent's understanding of complex situations. On RoboVQA, for example, performance is measured with a BLEU score, which is a metric evaluating how well the AI's text-based reasoning matches a human's. And once again, across the board, the ThinkAct model delivers the top results, showing that its ability to think is as strong as its ability to act. And this figure gives us a striking visual of that reasoning in action. What we see is the robot attempting to move a box, but it accidentally drops it. Now, below the images, we can see the model's internal monologue. It literally says, something unexpected has happened, and identifies that the box was dropped. Then, it actively replans and executes a new sequence to pick the object back up. This self-correction is a powerful emergent behavior, something the model learned to do on its own, and it really highlights the benefit of having a system that can think before it acts. So to understand what makes that self-correction possible, the researchers performed an ablation study, which is where you take away parts of the system to see what breaks. This table shows exactly that. The top row is the full ThinkAct model. The rows below show what happens when they remove the trajectory reward, the goal reward, or both. And as you can see, every time they remove a piece of that action-aligned reward system, the scores drop across all benchmarks. This test really proves that both rewards, checking the path and checking the goal, are essential. So, pulling it all together, the ThinkAct framework really offers a powerful new direction for embodied AI. By separating the slow, deliberate reasoning from the fast, reactive control, and crucially, by connecting them with that clever, action-aligned reward system, the model learns to handle complex, long-horizon tasks and even correct its own mistakes. This approach of using what the researchers call reinforced visual latent planning, where the model is rewarded for making good visual plans, seems to be a scalable path toward more adaptable and intelligent robots. That's all the time we have for this week's AI Research Roundup. Thanks for tuning in.